I've got my favourite Year 10 class here, period 6 on a Wednesday. And we're going to go through a few things. In particular, we're going to start with bearings. And this is something that usually students freak out about, bearings. It's not that bad. I can state a direction and opposite direction. We're going to go through some of those questions. We're also going to go through bearings with trigonometry. So before we do that, though, we're going to have to look at what is a bearing. Well, a bearing, often we have like what we call a compass bearing. And often we refer to what's called a true bearing. So let's draw out what exactly we mean by this compass rose. Now, look, you might remember never eat soggy wheat bix or whatever to get our compass, but we hopefully should know the difference between north, south, east and west. Just bearing in mind, isn't that cool? Okay, that in between north and east, well, you know what? If I was to start from north and work my way around, that is what we call the true bearing. It's the bearing from north, and it's clockwise from north. Importantly, it is clockwise from north. Okay, so let's do that now. First of all, by the way, I've done north, east, south, and west. By the way, there's actually halfway between north and east is what we call northeast. Wow. Now, let's think about it. If I go from north to east, and let's say if I start, I'm going to get a red pen. I'm going to get a red pen, and I'm going to start from north, and I'm going to work my way clockwise to east. How many degrees have I just gone? 90. So if I went directly east, if I went in this direction, I'm actually traveling at a bearing of 90 degrees because it's 90 degrees from true north. Okay, that's what we call walking in a straight line in the easterly direction is what we call 90 degrees. I can write T for true. If you want to write T for true because you're lazy and just want to write T, true, that's okay. I'm cool with that. I get that. If you want to write true, that's fine as well. Now, 90 degrees. Now, of course, where would northeast be then? If I wanted to go halfway, that would be northeast is a bearing of 45 degrees true. Okay, I might put that T for true there. Likewise, what would this one be? That's going to be halfway between south and east. So it's southeast, isn't it? Now, we know that south, if I'd walk directly in the direction south, let's think about it. If I'm starting from true north, how many degrees? 180 degrees, that's right. So if that's 180 degrees true, so what we might say, and this is what confuses students, is we say a walk is 180 degrees true south. We might not say south, we'll say walks for 5 kilometres at a bearing of 180 degrees. There you go, 5 kilometres. I'm walking in the direction south. That's what we mean. Then the person walks on a bearing of 45 degrees for 7 kilometres. Well, what would that be? Let's have a look. 7 kilometres. Would you agree that is 45 degrees? Like if that's 45 degrees, that is a bearing of 45 degrees from where we just finished off. Okay? So this is the sort of thing that students need to be able to draw. Okay, we start there, 5 kilometres, 180 degrees true, and so on. Now, of course, we could keep going. Southeast, by the way, 135 degrees. What have we got over here? Southwest, and that's going to be 225 degrees. West, of course, is what? 270 degrees. And northwest is going to be 315 degrees true. Okay, going around, really important. It has to be clockwise. We're not going anti-clockwise. We're always going clockwise for our true bearing. Would we ever ask something like a true bearing of 540 degrees? Do you think we'll ever ask a 540? No, because we're going around, we're doing one full revolution. We're back where we started, so we don't need to do that. Okay, so That's exactly what I've mentioned here in the key ideas. Let's go through and actually do these questions. Now it says A, B, C, D are 4 points as shown. Give the true bearing of each point from the origin O. What we mean by that is we are right there. We know that true north is facing in that direction. So the true bearing is always going to be from true north. We're looking at that angle there. We might be looking at that angle there. We're looking all the way over here, and so on and so forth. So be careful though. It says give the true bearing of each point from the origin. So OA is, well, let's rub this out. A little bit confusing, but you can see there that we've got 35 degrees to the horizontal. We don't want to the horizontal, do we? We want that angle from north, which means that that's going to be 55 plus 35 is 90 degrees. So we know that OA is going to be equal to 55 degrees true. Make sense? Now OB, let's do the same. OB, we know if I go from north to east, for each point from this diagram, I'm doing this one first, Marcus. Thank you. OB is this. We go from 0 to 90 to east, and then we've got another 45 degrees there. So 90 plus 45 is 135 degrees true, isn't it? Which we also could call, what would we call that on a compass dial? Southeast, yeah. Very good. Finally, we've got C. Now, if I go all the way around the dial and I walk all the way around to west, we know that west is 270 degrees, don't we? So if I've got 30 degrees to the horizontal, then therefore OC must be 270, take away 30, which of course is 240 degrees true. And finally, we also know if I go all the way around here, 270 plus 70 is 340, or there's 20 degrees left over, we know that that's 340 degrees true. Okay. Now, it says give the true bearing of O from A. I'm going to pause this because I'd like to have a little discussion with my class. Maybe you can have a bit of a think about how would we go about doing O from A. Let's read it quite carefully. We just had a little bit of a discussion about, how do we do, we have done O to A, O to B, O to C, O to D. What we want to work out is O from A. So in other words, if I start at A, let's draw a compass here. And if I go and look, you don't necessarily have to do this. Is it not a bit of a shortcut, which I hope that you start to recognize? But if I go from here, true north, and let's say true north is there, and I do a compass, I need to go around here and in this direction to head backwards. If I went in this direction to start with, if I wanted to go back exactly the same direction, but just the opposite direction, then we would need to walk in, well, over here it's 180 degrees. And obviously in here, we have drawn a triangle. And if I've got if this is 35 degrees, we worked out we have 55 degrees left over here. So that means that over here, this angle in here is 55 degrees. So the bearing, if I was to go to over here, to give the true bearing of O from A, that is going to be just like we did in blue, 55 degrees plus 180, that is 235 degrees true. Now, what do you notice though? O from A is exactly 180 degrees more than A from O. I'm not sure how an AirPod in your ear is a good look when you're supposed to be listening in maths, but anywho. These are learning behaviours I spoke about in parent-teacher interviews. O from D. Well, let's this time I'm going to pause this. I'd like you to try it. Let's draw a compass rose. Now, by the way, we don't want to go past 360 degrees. Before we had 55 and we added 180. What about if I go over here? Now we know that this is all the way over here. That was an angle of 340 degrees true. We already did that here. This time though, I want to go to O from D. So if I want to go from here to here, like so, can you see that? Let's draw an angle. What do we do? What do we have? Well, I want to go from there back to where I started. So I'd like you to have a bit of a go and think about it. If O to D was 340 degrees, what is D from O? What we've discussed is if I want to go from D to O, I need to go 90 degrees. Plus this angle in here, we've got 70 degrees left over. So that's going to be 160 degrees true. Notice, what do we notice about the difference between O to D and D to O? What's the difference between them? 180 degrees. Isn't that unbelievable? What I'd like you to do now, if you're watching this video or indeed you're in my class on period 6, on our favourite day, Hump Day Wednesday, it's middle of the week and it's Wednesday and it's period 6. I'd like you to pause the video, have a go, because we're going to go through our response really soon. When doing this, first of all, it says a ship travels due south 5 kilometres. Due south, they could have also said a bearing of 180 degrees if they wanted to. Due south is that what we have in blue. Now in red, I've also said step 2, draw a compass. Now I've drawn a little compass there, and notice 120 degrees true is I got to really start from direction north. You should really try to get teaching a class, period 6, with 7 conversations going and you've done maths all day. Not easy. Please remain quiet. This is for your benefit next week when we start forgetting what we've learnt this week and we miss out on athletic sports. This is for you, not for me. So 120 degrees true is, well, we've got to go 90 towards east and another 30. So that means this red line here is 120 degrees true. Would you agree that's 90 plus 30? This is actually a direction of 120 degrees true. What I suggest is draw a compass where you're starting at, and you need to just work your way around. 90 degrees would be to the east, 180 degrees would be more south, and so on and so forth. Now, from there, we're asked, how far east of the ship is it from the starting point? Well, we know that we've gone 5 kilometres. We need to get a diagram. I've got a 30-degree triangle. That's going to be 90 degrees there. That's going to be 60 degrees. Let's do A by using a bit of Sokotoa. What is this? What is this angle? What is this length? I'm going to call it X. Why not? Why not call it X? And I want to find what X is, because if I know what X is, I know how many degrees we are to the east. By the way, that's 30, that's 60. Though we do know that is the hypotenuse. We've got the longer side. We've got, you know what? I'm going to use the 30 degrees. Let's just, so we're not confusing ourselves, let's leave that. That is adjacent. That X is adjacent. So if I've got the adjacent and the hypotenuse, we're looking at cos. Cos of 30 degrees is equal to the adjacent, which we know is X, and the hypotenuse, which we also know is 11. So X is going to be equal to 11 times cos 30 degrees. We can get that over there, okay, which is around about, by the way, 11 root 3 on 2, but whatever that is, what is it?
9.53.
9.53? Yeah. I'll take your word for it, okay? So we're going to, now, how far east have they walked? How far east have they walked? 9.53 kilometres. Find out how far south the ship has gone. Well, you know what? I'm going to call this Y. Did we already not walk 5 kilometres south? Yes, so if I find what Y is and I add 5 kilometres. So let's do, how do we do that? Well, this time we've got the opposite and the hypotenuse. So I can go that sine of 30 degrees is equal to opposite Y over the hypotenuse, which is 11. And, you know, I did mention last class that we could actually work out what sine of 30. Sine of 30 is one of those ones where it actually is a lot. We can do it. Actually, sine 30 is a half, which means that it's 5.5 kilometres. So therefore, how far south? It's 5 plus 5.5, which is 10.5 kilometres. Okay? A lot of students answer 5.5, and of course that's incorrect, isn't it? Okay, here's your bearing challenge. If you're watching this video, I want you to pause now and try this. If you're in my class right now, I also want you to try this. I'm going to reveal my answer in about 3, 2, 1. Okay, here is our answer. This is exactly how I would work it out. A number of students who struggle are the students that don't draw diagrams, don't draw compasses. They just want to do it the nice short way. And you know what? In all honesty, if you do take shortcuts with this, you're going to make mistakes. You're not going to get the right diagram. You're going to get the wrong answer. There it is.